And then, all right, so this is the Math Foundations refresher. And again, if you are newer to CCRS Math Foundations, take in as much as you can. If it feels overwhelming, you're normal. And same for those who are reviewing. I feel like CCRS is it's just a never-ending journey in a good way. We're just always learning more or going deeper with our understanding. So um, the agenda for today. First, we're going to look at some resources and the CCRS levels and standards. Those kind of are going to go together with the resources we look at. We're going to do that piece more quickly. The part that I want to really focus on today are the shifts and the practices, like we mentioned earlier, because that's really the nuts and bolts of the standards. The lens, the perspective, how we want to set up our classrooms, the specific language of each math standard, which there are hundreds of, we are not going to cover in this refresher. But the shifts and the practices, which we will define, that is true no matter what level you're teaching, no matter what standard you're teaching. So that is what we are going to focus on today. We're going to review them. And then we're also going to do some math activities together, which will hopefully bring them to life. And we can talk about how we're seeing those. Um, just a heads up that this was designed to be interactive. So if you're able to use your chat, awesome, have that open. There will be a few times where I ask you if you're willing to unmute. I'm not going to force anybody, but if you're willing to unmute, that'd be awesome so that we can have other ideas besides mine, because it's best when we're learning from each other. So just to start off, this graphic may be familiar to you. It may not be, which is fine. But the Minnesota Adult Education Content Standards are pictured here in this graphic. And there are three sets of standards that Minnesota has adopted for adult education. The digital literacy skills, North Star Digital Literacy Standards addresses that area. For the transition skills, Transitions Integration Framework, ACEs, TIF, if you've heard that, that framework addresses the transition skills that we've deemed our students is worthy of our students' time and attention. And then the college and career readiness standards really define the academic skills. And this is where we're going to be today, specifically in the math portion. We don't get this question as much anymore, but it still does come up. Like, do we have to teach to the CCR standards? And the answer is yes, because alignment to K-12 standards is required by WIOA. And the CCRS standards were formed based on the Common Core standards, which were for K-12, but a little bit altered a little bit for adults, and some things were left out and kind of choosing what's most important for adults to learn. So it is based on K-12 standards, and which is required by WIOA. And so like I said, our Minnesota Adult Education Office at MDE chose those three sets, CCRS, TIF, and North Star, as the standards that we will use to guide the development of student skills in the transition skills, digital literacy skills, and academic skill areas. And then adult education programs do need to document how they're implementing standards through periodic applications for funding. There's the program review that happens, I believe, now every 6 years or so. And so there are questions to ask how programs are implementing these standards. So that's a little bit of an overview, like where do these come from? And And then this is kind of more of a heads up slide that I'm not going to share the link to the Padlet yet, but I want you to know everything you see today, you will get access to this Padlet at the end, so that all of the resources you'll have, the resources, the activities, extra tutorials, etc. You will get that list of resources at the end here. So, One other piece that I want to bring up, let me just go. Yeah, one other piece I want to bring up, and before we get to specific CCRS math, has anyone seen this resource before or something like it? You can say yes, no in the chat. Um, a resource kind of connecting, I think so, yeah, connecting the CCRS levels with the NRS approved assessments. Awesome. A lot of people. Everybody so far. It's great. If you haven't, we recently updated it. And so this is on the Padlet, but CASAS goals and goals two specifically for math, goals two, and then table 1112 and 1314. 1112 is still viable till the end of this program year, June 30th. But there is some correlation here to CCRS levels and the scores that students are getting and the grade level equivalency. So this isn't a perfect table, but it does give us some idea of the connection and when we're counseling students or placing students in classes and talking about progress and the college and career readiness standards informed these assessments. And so that is why they are so closely connected. All right. Any questions so far about the large picture resources before we dive into math? Practicing my wait time. All right. The CCRS Blue Book. This. Call it the Blue Book for obvious reasons. It's blue, but it's also easier to say. So with math, for math, there are two different resources that organize the standards that we have. The Blue Book, standards are grouped by level, and the content progressions document, where standards are grouped by domain and topic. Now I'm going to pause there for a second, and I'm going to go to the Padlet. I'm going to pull up resources as we're going throughout on the Padlet so that you hopefully become familiar through watching me navigate it a little bit. So it's not as overwhelming when you get the link later on. You will get access to the slides. There's that chart. But here's the Blue Book. Does anybody use, well, I'll say this. Do you use the paper version or the online version? Which ones do you prefer? Paper? Paper? Because I should have it right here. Yeah, I do. There's the big book that's like, I don't know, 300 pages. Paper if you can find it. Yeah, exactly. Um, the paper is an awesome resource. So here's my book, all the tabs and everything. I I love the paper version. I also love the digital version. So I did upload this PDF here for you to have that. But if I were to go to this online version, I use it for different reasons. I love the Control F function. And so I am going to do Control F, and I am going to search for a random standard. I'm going to do 8.f.1. Okay. If I am looking for a standard and I'm like, what level is it in? What context is it in? What grade level equivalency is this? And I want to see what other things are addressed. I use the Control F function because I don't have all of the standards memorized. And so here I can see 1 out of 3 times, it brings me right to the page where that standard is listed out. I love the Control F function. If then I scroll up to see, well, where does this level start? I'm going a little slow because otherwise I feel like it's dizzying. This is going to be in level D. So now I can see level D, and I'm going to stop here for a second and make it bigger. The Blue Book um, divides the standards into A, B, C, D, and E. Um, as you saw on that chart with the CCRS assessments that most of you said you've seen, level A is really that kindergarten, first grade level. B, second and third grade. C is fourth and fifth. D, sixth through eighth. And E is more high school. The interesting thing about math is that sixth grade is actually, some are in level C, some are in level D, some of those standards. So for those standards, I have to kind of look up, like, is that in level C or level D? But with each of these levels within this blue book, you get a summary of that level. So level D at that sixth through eighth grade middle school level, you get a summary, and then you get all of the standards at that level, regardless of which domain it is. So the number system standards, those that are part of, excuse my scroll, expressions and equations. You get ones that have to do with functions, like the one I searched for, geometry, etc. So you have all of the standards within a level grouped together. And if I were to go to page, I think 60, ooh, close. 59 in this electronic one, level A, where I could have started, but I just wanted to go to functions apparently. Again, you see another example. There's that summary of what is taught there, and then all of those standards are listed in level A. So that is one way of organizing the standards, which is why I say that they're grouped by level. The other document is called Content Progressions Document. And this is where standards are grouped by domain or topic. And so here, I will scroll slowly through this. And my question to you is, what do you notice about this document? They're all the same standards, but they're organized differently. What do you notice as I scroll? And there are lots of right answers. Anything that you notice, this document looks different than the blue book.
All the grades seem to be together under one level. Is that what you're looking for?
Say that again. All the what are together?
All the grades seem to be together under one level.
Yeah. So like under one topic, all of the grades are together. Yes. So I started with, I'm going to keep going here because I think I'm almost to the algebraic one. Whew, this is a long one, the number system. Algebra and functions. Now I'm starting back at level A because you saw the previous section, we were in numbers, and it was level A all the way through level E. And this now it's algebra and functions. Level A starting because they're in first grade, they're thinking about unknowns. So there is algebraic thinking in level A. And it's showing a progression. Okay, then what comes next, right? How do I get from level A to level B in this area? And so it's showing this in a progression. And so, yeah, natural stair step of skills grouped by topic with all levels. This is another document that you may have received a printout, either at an event, an Atlas event, or if you were a part of a CCRS cohort or the foundations in person. Otherwise, we have it online. But this is another one that I like to also use the electronic version sometimes if I'm trying to find a standard and where it is. In adult ed, I think this is true of any educational setting, but especially in adult education, I think this document is very, very helpful, and teachers have found it very helpful because it helps us identify gaps. Our students come in with different gaps. No student is the same. And so if a student is struggling, say with this standard here, they're struggling, I might think, okay, what is coming before it that maybe I want to back up and see what some gaps might be in this progression. And it can be a way to intervene. If a student is needing to be challenged, but maybe this is what is being focused on, like, okay, what comes next? How do I build off of this standard? What logically comes next? And so this can be a very helpful document, exact same standards as the Blue Book, just organized in a different way. It is not only online, but it is a lot of, I mean, I guess it's only 28 pages, but it's still 28 pages. So it's several pages to print. I know that we've handed them out in person at different events. But I did link the online here, the content progressions. So you do have this document available to you. So those are the two like main resources for math. They just organize the standards in different ways. And then the glossary of terms. This is another resource that you don't have to use now, but I want you to know that you have access to it, that there are so many terms, so many acronyms. It's like, what does that mean again? So there's also a list of terms. There is a PDF version on the Padlet, and then in the slides that you have access to, it will also link to this page here, a Google Doc. But you have access to all of the key terms, and towards the bottom, the key terms for math are here, and the shifts and how they are defined. So that is directly under here. If you like worksheets, there's a fill in the blank worksheet to help you work through some of these terms. You can kind of test yourself. We're not going to do that today, but I included it here for those who might like that. All right. Any questions on, or what questions do you have about these core resources? Okay. We're almost done with this portion. The last piece I want to make you aware of or remind you of is another resource to help make sense of standards. So with these, like this is a first grade standard, level A, but it is very long. Like there's a lot happening in this standard. And so there's no way that we're going to teach this whole standard to a student in one session with them, whether it's a class or one-on-one. Like there's a lot of different strategies named, methods, understandings, etc. So to help us as teachers before we're working with students, or if there are certain standards that are always confusing because of the language, there's an optional resource to use on your own, with a colleague, in a PLC, to help break things down. And so I included this worksheet under its own category. I have a lot of resources developed around making sense of standards. So here's this worksheet where it kind of takes you through 5 steps. If you've done the online course, you've done this work already to practice. If you haven't, that's okay. You have access to it here. But thinking about, okay, how would I break that standard up into manageable chunks, manageable sections. And you might find that there's like five different sections, especially because add and within 100, including adding a two-digit number with a one-digit number, adding a two-digit number and a multiple of 10, using concrete models or drawings and strategies based on place value, properties of operations, and/or the relationship between addition and subtraction. Relate the strategy to a written method and explain the reasoning used. Understand that in adding two-digit numbers, one adds tens and tens, ones and ones, and sometimes it's necessary to compose a 10. So there are lots of different things in there, lots of different pieces, places where you could break it up, to say, okay, I'm going to focus on this aspect of the standard first, and then I'm going to talk about using concrete models or drawings, or I am going to talk about just the strategy based on place value first, and um, break up some of those that are listed, talking about properties of operations as another strategy, the relationship between addition and subtraction. So there's various ways that you could break this up, and I don't think that there's one right way to break up a standard, but it's the idea of engaging ourselves in making sense of it for ourselves so that we can help students make sense of all these different pieces. And this worksheet is meant to help with that. Maybe there's five different sections, maybe there's two, maybe there's only one if it's a short standard, but um, kind of breaking that up and then trying to make meaning of each of those sections. Here are some guiding questions. Um, what are students being asked to do? What content are they being asked to know in these phrases? How are they expected to demonstrate their understanding? Are they supposed to write in words? Are they supposed to be able to draw a model? Like, what are they supposed to be able to do? Can I reword this to make it make more sense? So you would write some notes here. You can write objectives and learning targets. So, okay, students will be able to, in teacher language, but then how would I put that learning target on the board in student-friendly language? When students have mastered this part of the standard, I can add and subtract two-digit numbers, or I can something that is kind of gets the flowery language away. Thinking about strategies for each section, and then thinking at the very end of this reflective work, how do all the pieces of this standard fit together? Yes, there are maybe five different things that I could break this one standard up into, but why are they all still within the same standard? What's the relationship? So again, there isn't always one right answer to this, but it's the idea of engaging with them. And so this resource, I wanted to remind you of or make you aware of that you have access to this. And that was a very quick overview. And so there are videos. So if you're a video person, or you want to pause and go back, unpacking a standard, just the process, there's a video for that. Um, the green are I signaled with videos. Walking through the template more in depth on how do I even fill this in? How would I use this as a learning tool? And then if you want to see an example of a standard and how I broke it down and how I answered each of those sections, that is here as well. So this idea of making sense of a standard, if that is something that you want to dig into after today, there are resources here available for you. All right. The fun part begins. If you weren't having fun already. Okay. So so that was an overview and a reminder of some of the key resources and reminding us of the different levels, and the tie back to our NRS assessments, just kind of getting all that information fresh in our minds again. The resources of making sense of a standard, if that's something that we want to dive into. But the bulk of the time, like I said, we're going to be spending on shifts and practices. So, does anybody remember what one, two, or all three of the math shifts are called. We have rigor in the chat. That is one of them. Yes. Anybody remember any others? Focus. Yup. Okay, we got two of the three. It starts with the C. It's about connections, but it's not the word connections. Coherence. Yes, exactly. So those are the three shifts. And these are instructional shifts. So I love it. You can cheat. That's fine. It's not cheating, it's using resources. So we have the instructional shifts with all of the overwhelm of all of the standards that I was like scrolling through and not pausing and maybe making you dizzy, looking at what something that all of the levels A, B, C, D, E have in common is that we are supposed to, as instructors, create our instruction, design our instruction with these instructional shifts in mind. This is the lens that we look through. So, focus, coherence, and rigor. When you hear focus, what do you think of? If that's a value of these standards, if we're supposed to focus, what do you think that means? And you can unmute or you can put something in the chat. One topic or skill. Target in on one topic. I love it. Like, let's go a mile deep and an inch wide versus an inch deep and a mile wide. It's very intentional. And from classroom to classroom, it might change depending on the goals of the students in front of you. Another way of trying to decide what do I focus on? One is the goals of your students. The other is this document. If you see a bolded standard in the progressions document, it's called a major work of the level, a model. And if I keep scrolling down, I'll see like this. This is in italics. This is not bolded. It's not that it's not important. There are students that need this, or there is a reason to focus on it. Yes, but it is supporting what experts have labeled the major works of the level. So if you're wondering like how do I focus, what should I focus on? You can start with the bolded standards, the models, and also coupled with the goals of your students, and what that looks like. Because we can't teach everything, even though we want to. And I was in the classroom for 10 years, and I feel like that was one of my biggest struggles to the day that I left is everything's important. I want them to know everything, like, but we have to make decisions or there will never be a deep understanding of anything, right? So coherence, making connections between level A and level B. Progressions document is great for that. Making connections between geometry and algebra, between fractions, decimals, percent, so they're not thought of as separate things, but oh wow, there's the same way of writing, different ways of writing like the same number, right? Talking about similarities and differences, giving students an opportunity to make connections so math doesn't seem like isolated topics, which not everybody's education has been that way, but a large percentage of our education has been like math in siloed topics, and it doesn't mean anything. It doesn't mean anything in real life. Which brings us to rigor. Three pieces. And this stool kind of illustrates we need all three of these legs for it to stand. We need to be developing conceptual understanding with our students. It needs to be applied to real life. Why does this matter, especially with adults? Why is this relevant? And the procedural skill and fluency, the practice, the worksheets. I hesitate to say worksheets or drills because I don't always love how we've used them in the past, but there are ways to use those well, but we have to do that and develop conceptual understanding of why this works and how this works and what's the relationship and applying it to real life. All three of those are what make up rigor. Focus, coherent, coherence, and rigor. Those are the three shifts that we as teachers need to use as we are planning our lessons. So in the chat, I'm going to put up some quotes from past participants, past CCRS Foundations participants. And I want you in the chat to write if you think it's focus that they're describing, coherence, or rigor. Okay, so three options: focus, coherence, or rigor. Here is the first quote. Focus, coherence, or rigor. And it's okay to be wrong. You learn more when you say something wrong and then learn what the right answer is than if you guess right all the time. I love it. Okay, we have all three answers in the chat. This one, because it is referencing the three, it is rigor. One part's not more important than the other, and every lesson doesn't need to include all three. So these are the three that are being referenced: this conceptual understanding, procedural skill influencing, application. And my fault, forgot to mention why this is a three-legged stool is that they are equally important. Like your stool's going to wobble if one is longer than the other. It doesn't mean that we're doing them all in every lesson, but over the course of a topic, students should be getting instruction or activities that help develop all three of those. So that one is rigor. What about this next one? What do you think? Focus, coherence, or rigor? Yes, this one is focus. Okay, next one. There are several of these. So it'll, again, just helping us identify focus, coherence, rigor. Which one do you think? I love the abbreviation of coherence. I see it, Heidi. Okay, I thought you were abbreviating. I like that. Okay, but yes, coherence, linking it to what they know, right? What comes before, what comes next. Um, all right, what about this one? I love the idea of this shift because it gives me permission to not cover everything. Teach the standards that give the biggest bang for the buck. Yes, focus. Okay, next. Build a solid Jenga tower. The more concepts that are missing, the harder it is to succeed. There are too many holes, it will come tumbling down. Yeah, this one I feel like is tricky. I feel like you could make a case for a couple of them. This one, the teacher was describing coherence, um, because of needing to have things connected and making relationships between them, um, and having those gaps filled like a Jenga tower. What comes before, what comes after, how are they related? And so, yeah, but I see why people said rigor because coming at a topic from different areas of concepts, procedures, and application is also important. All right, next one. Hmm. Yeah, not just doing it for no reason or for those rote procedures, but like, why? What's behind this? All right, a few more, and then we'll move on. But this repetition is helpful, for me at least. I love the unanimous response to this one. And so you are making me look at this. I think, can someone tell me why you were thinking coherence? I think you have a point. I'm just curious. Is someone willing to unmute and share why you think coherence?
I chose coherence because it pulls together the levels of the skill. So it's within one skill, kind of, but it pulls all the levels together.
I like that. Yes. Okay. Fluently move between, yeah, pulling at different levels. What
I
about
cho
everybody's? Go ahead.
I chose coherence because of the definition of coherence, making connections. And when you are trying to teach somebody what a linear function really means by plugging in those values and how the answer changes, if you can make that connection to something in real life, um, then it's going to become meaningful to you and you'll understand it at a deeper level. Now, as I just explained that, I can see how somebody would go with rigor because the real application in rigor is exactly what's happening in this example.
Yes. I love that, Tammy. You just beautifully said that because, and I think for some of these you could make a case for both. So thank you for sharing about why you saw coherence. I agree. And which is also nice that there's some overlap with these shifts because if we are doing one, then we might naturally start doing the other as well. But as you were saying, building the concept, applying it to real life to help make those connections really is that rigor too, right? Conceptual understanding, procedural skill and fluency, and applying it to the real world. But that feeds coherence and making those connections. So I love it. Okay, what about this one? Yes, this one is definitely coherence for all the reasons that you all just said. All right, I think we have just two more that we'll do. Yes, and something I love about this quote is it reminds me, like helps put it in different words for me, like the importance of focus so that students don't forget, right? Like I feel that if we're not applying these to the real world and we're not owning that understanding, we don't go deep with something, it's easy to then forget and then we can't apply it anywhere else. So, really focusing our instruction, not trying to cover everything. All right, last one. Yeah, I think you could make a case for a couple. I see coherence and rigor, and I think you could make a case for either. This one, the teacher was trying to describe rigor to them, the different aspects being the conceptual understanding, the procedural skill and fluency, and the application. But again, this is also describing coming at it from different angles, making connections, what comes before, what comes next. What other things does this relate to? I think you can make a case for coherence as well. All right. How are we feeling on a scale of 1 to 3? 1 being like, I feel shaky. 3, I think I'm pretty comfortable on the meaning of focus, coherence, and rigor. 1 is real shaky. 3 is, I'm pretty okay with it. Where are we feeling as far as just identifying what they mean? I'm so glad you're giving yourselves 3 because I would have given you all a 3 based on your comments and your justification even for when something was different than what the screen said. So I'm glad that you feel the same. All right, we are going to do one more brief section before we take a stretch break. And then after the stretch break, we get to do math. Okay, so it'll be super fun. But first, math practices. Can anybody name a math practice? Oh, Heidi, I saw your 2.8. I really appreciate the decimal. Thank you for making that scale your own. Can anybody name a math practice? It's okay if you can't. There are 8. I'll just give you space to think. And if you want to look it up, you can. That's fine. Use your resources. Yes, I love it. Page 48 in the blue book, if you have it. Really gonna go there. What's happening here? There we go. Not going to do it. All right. So, and that's fine. So here is the blue book, or page 48. A little bit further on if you're using the PDF, but the online version, I mean. So the first one, make sense of problems and persevere in solving them. That's math practice 1, and there's a paragraph which we're not going to take time to read now, but that's the first one. The second one, reason abstractly and quantitatively. Can I go from context to symbols and then from symbols to context? Can I go back and forth? Because sometimes we see math sentences that are very abstract with just symbols, but then can I tell you with like from the word problem how that matches those symbols? X plus 3 equals 5, or maybe it's 3 plus 2 and there aren't any unknowns or whatnot as far as like x's and things to solve. Still symbols, but can I tell you that it's talking about adding up boxes of donuts? Like can I tell you what each piece means? Decontextualizing it and then contextualizing it. Constructing viable arguments and critiquing the reasoning of others. Modeling with mathematics. We're going to look at more of what these mean in a moment, but modeling with mathematics. Using appropriate tools strategically. This one I will say, I know I'm not stopping and explaining each one, but this one, it really is, can students do this? Can students eventually choose which tool they need to solve a problem on their own, right? Attending to precision. Two more. Look for and make use of structure. And then look for and express regularity in repeated reasoning. So these are the 8 math practices. I have them here on the screen again. And my question is, if you had to, I'll go back to that screen in a moment, but if you had to talk about the difference between the shifts and the math practices, what would you say? I'll give you a moment to think. You can put something in the chat too, but if you want to unmute, feel free. What's the difference between the shifts and the math practices?
I think that each math practice would involve one or more of the shifts, or all of them.
Do you say more?
I would say one or more, or all 3.
Yeah. I like that. Okay, why do you say that? I really like this thought.
Well, each of the practices would include focusing on that, using your scaffolding and teaching it, and building on the rigor and so coherence, rigor. It would use all of them, or if you want to focus on it, the one thing.
I love that. Thank you for sharing. I see abstract to applicational. Are you saying, Julie, the abstract more the shifts and then the applicational more the practices?
I'm just saying, oh shoot, can you hear me? I guess I
Yes.
don't have my mic on. Okay. That, the shifts seem very abstract as far as a teacher, what you're going to look at, but the practices are the things the students are actually going to do, right?
Which goes back to what Heidi was saying too. Yeah, the practices are things students need to show, and the shifts are really about the teacher. And I agree that they seem more abstract. And then Cindy, I really like your point that because because the math practices are what we want students to be able to demonstrate and give them opportunity to make sense of problems, give them opportunity to reason abstractly and quantitatively, and so forth. Those shifts, because this is how we're supposed to be designing our lessons, are all 3 of those could be seen in those math practices, as far as the design. So I love it. Yes, teacher lens versus student behaviors. That's how they are packaged. And there's lots of overlap, but this is how I am planning my lessons. Am I focusing? Am I making connections, giving students opportunities to do that? Coherence. Am I having all the different elements of rigor throughout a various lesson? And then the student behaviors, I still as a teacher have to give students opportunities to do that, the way that I set up the activities, etc., what I'm asking them to do. But I want to eventually see these behaviors from my students without me prompting them, which is why I kind of highlighted the use appropriate tools strategically. If I tell students, use graph paper to help you think through this, yes, they're practicing using appropriate tools, but when they can identify, oh, this is the problem, I think I'm going to go get some graph paper. They're taking ownership of that and they're able to make that decision. Or I think a table would be really helpful here. Using the right formula on the formula sheet. Yeah. Are they moving into the decision maker in that sense so that they are the ones making those strategic decisions? And it happens through scaffolding, right? Like we have to help more so in the beginning. All right, so we're going to look at these practices in 4 groups of 2 before we pause. The first group is math practice 1 and math practice 6. And those, again, are making sense of problems and persevere in solving them and attending to precision. And experts group these together in a topic or in a category overarching habits of mind of a productive mathematical thinker. So just to yourself, you don't have to put anything in the chat. Why do you think these ones are grouped together? Just think to yourself. And then I am going to read this quote. This is from a Foundations participant who is responding to that question. Why do you think these are grouped together? The continuous planning, revisions, and perseverance involved in students' problem-solving efforts will undoubtedly rely on and be enhanced by the precise use of language, symbols, numbers, etc., encouraged in MP6, especially when considering the idea of explaining and discussing their reasoning. Students will need to rely on their ability to interpret and analyze precisely what they're doing each step of the way in order to be ready to make changes if necessary. My question to you, as far as why these 2 are grouped together in overarching habits of mind of a productive mathematical thinker, what stands out to you about the connection from what you see on the screen? Are there any phrases that resonated with you about why these 2 are connected? Or is there something you'd like to add? You can unmute or you can put something in the chat.
I hadn't thought of using I hadn't thought of this in terms of using the correct units, but that can be so important when they're solving, especially geometry problems and things like that. So,
Yes, thank you for saying that. You're right. Units are so important. Um, some people call no naked numbers, right? Like 15 doesn't tell me anything. Is it 15 square units? Cubic units? Like what are we talking about? Feet, dollars? So yeah, thank you so much. That's part of precision and making sense of a problem. Cindy says, just watch the movie Hidden Figures and you'll see why. Yes, we would not have landed on the moon without precision and perseverance. That is a great movie to bring up for this. Yes. Continuous, precise use of language. Love it. Okay. Next group. Reasoning and explaining is the next category. Math practice 2. Reason quantitatively and abstractly. Construct viable arguments and critique the reasoning of others. Again, to yourself, why do you think these are grouped together? Take 30 seconds just to yourself. Is someone willing to read this paragraph from this quote?
I can.
Okay.
To reason abstractly and quantitatively, a student must support their arguments with facts from the solution. To do this, they must construct an argument to explain their solutions or question the misconceptions of a classmate.
Thank you. So my same question to you, what stands out about the connection from what this participant said and or is there anything you'd like to add about the connection you see between math practice 2 and 3?
Sometimes you have to be able to show, like with a diagram or with some sort of a graph or a chart that explains why someone is wrong or why you're right. But in order to do that, you have to be able to solve the problem quantitatively so you can show it. I don't know. I'm having trouble.
No, you have to be able to solve the problem in multiple ways, right? Like, can you quantitatively show it in symbols and then also say what those mean in order to prove your point, right?
Mm-hmm.
I like it.
I would like to add something here. What really stands out is that my past experience in the math classroom has been if a student gets an answer which is similar to the person sitting next to them, that is their reasoning that yes, it must be correct. Or if a student gets an answer that matches one of the 4 multiple choice answers, then that must be the reason and it must be correct. What I really, really like about this is that they really have to support the reasoning, their argument that it is correct. And it's not just because, most of the people in the room got it or it matches letter B on the test. And so it is much, much deeper thinking than just working out the problem.
I love that. Yes. Yes, I totally agree. And as you were talking, I was reminded of some tips that others have shared with me. I did not come up with this, but like we sometimes have that student that knows all the answers or is ahead of a lot of students, and they want to share their answer right away, which can skew then how other people are thinking about it. And so one tip that I learned was to challenge that student. Okay, don't tell me the answer. Can you create a hint? Can you create a hint for how someone else could get to the answer? And this is just off topic, I'm sorry, kind of related though. But then that challenges your thinking. I can't give you the answer, but I have to give you a hint so someone could get to the answer. Can buy some time for other students to be able to reason. It's like, oh, wow, that's fascinating. Okay. So anyways, that made me think of that. And the other one left my brain. So I said there were a couple, but that one stuck. So we'll go with that. Thank you both for sharing. 2 more groups, modeling and using tools. Math practice 4 and 5. Model with mathematics, use appropriate tools strategically. Why are these grouped together? Think to yourself first. All right, so someone said practice 4 and practice 5 have been grouped together because they're both focused on using what we already know and have experienced in the real world to solve problems. Practice 4 asks us to recognize math in everyday life, create models that will help us determine if we're answering questions correctly. Part of creating models that work is determining which tool is best to use in that situation. So these practices really do go hand in hand. This is especially good for teaching math for the trades. Do you want to say more, Cindy?
So one example at Summer Institute was teaching them how to read the and I just drew a blank.
I do it all the time.
The measuring,
Yes.
how to measure things
Yep.
and using 16th inches and things like that.
Yep. Exactly. I love it. That's connected to everyday life, construction. Uh, that tool. Anything else folks want to add or call attention to from this group? I love this sentence. Part of creating models that work is determined by which tool is best to use in that situation. So, or determining which tool is best to use. So they really do that help me think about it too, as far as like I'm going to create this model, but to create this model, I'm probably going to have to strategically choose a tool to think through.
I'm thinking too, like students that are studying for their GED always seem to get intimidated when they come to a word problem. And
Yes.
really, it might be a word problem that if they just remember how to use one of the geometry formulas, it'll be really easy to put together and come up with the right answer. But that can be a stumbling block. I mean, word problems seem like they're trouble because they don't, students don't feel very directed mathematically sometimes. So remembering to use a formula or a calculator button can make it a lot easier or
Yes.
less intimidating.
Yes, exactly. No, I love that. And I always um like I'm in favor of using calculators. Um, the only reason I wouldn't want a student to use a calculator is if the goal of the lesson was some sort of procedural fluency. Otherwise, like you're saying, it's a great tool to take away some of that cognitive load so they can focus on trying to make meaning of the task in front of them. And you get the calculator for most of the GED test. Last one, scene structure and generalizing. Looking for and making use of structure, and looking for and expressing regularity and repeated reasoning. Think to yourself, why are these grouped together? And here is what someone else wrote, making sense of why they might be grouped together. I'll let you look at this and then comment on that same prompt. What connection are you seeing and what would you like to add? I think these two practices are, for me, the easiest to get mixed up because they sound so similar. But I appreciate how this person kind of pulled out, like one is where we're trying to take this idea and then look for the smaller patterns, the smaller structure that helps us make sense of it. And then in math practice 8, we're actually trying to look for that repeated reasoning that then help us, the smaller pieces that help us make a generalization that we can then apply in other situations. So yeah, that opposite directions, going from big to small, small to big, to use that reasoning and structure to apply elsewhere. Yes, reminds me of pyramids, building on the same size blocks to make a giant pyramid. I love that. Okay. On a scale of 1 to 3, before we take a break, how comfortable, you don't have to be able to list them all like from memory, but how comfortable are you feeling with the meaning behind these practices? 1, very shaky. 3, yeah, decent, pretty good. Like we don't have to be an expert to be a 3. Like, yeah, that kind of makes sense. All right. So I just want to point out, um, yes, thank you for your honesty with the 2 and the 1.5. Yes. Um, two Here on this Padlet, there is a PDF of the groupings of the standards. And it gives some pictures to kind of, and some other kind of keywords to maybe make sense of it. So there's one visual there that I included. I also have a handout that you could print and put in classrooms or share with students online. But the practices and then them written in student-friendly language, a way of kind of rewording them, um, that may help students think through like, what did I do today? How could I kind of name some of the skills that I'm working on? So that is in this resources as well. And then the last piece is with the math practice, or sorry, the math practices, we have webcasts that were made a while ago, but they still are very strong videos that I believe other states use. But talking through one practice at a time. So the link to where you can find those on our website, you have math practice 1, 2, 3, and each one gives examples of what it might look like in a classroom with problems. It has a clip from a classroom. To kind of bring one of those math practices to light. So if that is something that you would like to personally dive more deeply into, that is under the videos and tutorials here. And so, yeah, I just wanted to point that out. I love visuals too. They help me a lot. All right. We are going to take a 3.5 minute break. I apologize for not giving you a 5 minute break, but I want to have some time for this math coming next. We're gonna have fun, I promise. But 3.5 minutes. As you're uh refilling coffee, whatever you decide to do, tea, or just stretch and look away from a screen. If there are lingering questions, please type them in the chat. Think about them and then come back and type them in the chat. But let's take 3.5 minutes and then we'll return. All right, I know that was a quick break. Are there questions that you want to add to the chat before we move on?
Do you like Padlet better than Jamboard? Or did you ever
Hmm.
use Jamboard?
Yes, I use Jamboard all the time.
Hmm.
Um, Padlet Sandbox, I think is the best and simplest alternative to Jamboard. I don't think anything's ever going to really compare to Jamboard, but I do like um, the Padlet Sandbox feature. I've tried other things. I've played with Miro board and oh, what else? Fig Jam, and I feel like those ones have almost too many features. Padlet
Hmm.
Sandbox seems to be the most similar. But yes,
Cool.
I miss Jamboard.
Yeah, me too. Thanks.
Yeah. All right. So, this is just a kind of summary statement about the shifts and practices, trying to anchor them in our minds, like the differences, but also how they are related to each other. The CCRS math shifts and practices emphasize the importance of teachers intentionally creating the environment in which students make sense of math ideas. So, as we do some example activities, the key thing I want you to be thinking about all along are what shifts and practices are you seeing or experiencing or even see the potential for with an activity like this. So I'm going to go out of order. I switched it up. We're going to start here with a which one doesn't belong. And I am going to ask you um, in the chat to, in 30 seconds, so not yet, I want you to think of these four options, which one doesn't belong? And in 30 seconds, I'll invite you to share. All right, if you've made your decision, please feel free to share it in the chat and include why did you say that? Which one and why? If you've already shared yours in the chat, make sure you're scrolling up or whichever way to see what other people are writing as well. Okay, so we've made a case for almost all of them. I think just the top left we haven't. Um, and some reasonings are different. Some are saying that this pentagon, because it has five sides, others are instead of four. Another person said because it doesn't have right angles. Um, this one is the only one filled in. This one's not perched on a base. Could we come up with a reason why this one wouldn't fit? And if I missed it, please let me know. Ooh, equal sides. This one does not have equal sides. These three do. So we came up with a reason for all four, in which one doesn't belong. And if you look too at what people wrote in the chat, there's a lot of opportunities for developing language. I see pentagon, sides, equivalence, right angles, um, uh, base. There's a lot of language there. Okay. We're going to reflect on it in a minute. Here's another visual. We're not going to do this one, but I thought this one looked fun. If people use algebra tiles, this might look similar to that. Numbers, fractions. I would like to do this one again. So take 30 seconds and think on your own, which one doesn't belong and why? First, just think about it. All right, you can compose an answer in the chat. Remember to type a reason as well. Which one doesn't belong? All right, we have two so far chosen. The top right, because it's the only one that goes through 0, 0, or I saw someone name it the origin. We also have the bottom right, because it is the only one with a negative slope. Okay. Can we think of any reason why the bottom left one doesn't belong? Yes, it's pictured under the x-axis, which means that, Heidi, it has a bottom left negative y-intercept, or it has a negative y-intercept. So with, well, no, I'm not going to say that. Here's one more example of an image. You could do parabolas and quadratics. All right. I have a few more things I want to point out about this, but you may, so I don't want to say any more yet. So I'm curious. Okay, we did that fast and furious. This would take a lot longer to do with a student in your classroom or with a group of students. But what shifts and practices did you see or experience, or what do you see the potential for? And I've listed them here as a reference in your thoughts, but feel free to unmute or write something in the chat with an activity like which one doesn't belong. What do you see the potential for, or what did you experience? Julie says MP3 for sure. Having to construct, yes, we definitely demonstrated MP3. Having to construct that viable argument. And I would argue there's a potential, I didn't do this here, but there's a potential for then having students critique the reasoning of others. Whether that is, saying, oh, what do you think of that? Instead of you saying, yeah, 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 turning it back to the group. Or if you're in a one-on-one situation, having something prepared. Hey, another person said this. What do you think? Right? Like have another thing even on paper for them to interact with, if you do not have a group. Any other practices or shifts? Potential for or that you experienced?
I just wanted to share that I really thought that it was nice that we did multiple examples in a row, because I agree with what Heidi just put with focus, that, my thought process got deeper into the thinking the more we did them, rather than just looking at the most obvious thing first.
Yeah. Thank you for saying that. And I think too that, again, for students who are able to come up with one right away, challenging them or the whole class, see if you can find a way why this one wouldn't belong, right? Like, so these prompts have changed the way I think as well, because I resonate with what you're saying. Um, and I also think that because there's some obvious and then there's some that I really have to think about. Because a good which one doesn't belong, there is a reason for all four of them. But it's a low floor, high ceiling task. There are lots of things that can be said so everyone can have access to it, especially if we're in a multi-level situation, right? Like if someone is saying that line goes up or that line goes down instead of up, right? They may not have the words yet for a positive or negative slope, but they're able to contribute. Or if it's like this one where it's more about this one is filled in, this one's colored in, and they're not sure about how to talk about the sides or the equivalents or the right angles yet. There's still an option, but then there's also a high ceiling where those who do have that knowledge are able to bring it to the table. So, yeah, I like that. Your own thinking was going deeper. Engages higher order thinking, yes. And I think attending to precision is also here the potential for, because yes, people can say things, but then you as a teacher can also help zero in on some precise language. There were lots of vocabulary words that we know that we put in the chat, but not everybody does. And so using that precisely. All right. I will leave it there for now. Let me just make sure yeah, yes. Let's do this one. Always, sometimes, never. So, Joaquin received a 5% raise and I received a 10% raise. My raise is larger than Joaquin's. Is that always true, sometimes true, or never true? And how do you know? So again, you can compose something and put it in the chat, but be sure to include a reason for always, sometimes, or never true. All right, what I would like you to do is look back at what someone else wrote and use one of these sentence stems. You do not have to do all three, but just respond to someone in the chat. I agree with so and so because, or I disagree with so and so because, or I'm puzzling over what this person said. Can you explain? So use one of those three as you look at someone's response in the chat. I love this discussion happening in here. Like, do we take this at face value? What, going back and forth. So, um, I hear you, Cindy. Like 10% is always higher than 5% if we're talking about the same base. So thinking about this as face value and like how it was written, it might be confusing. If we look at this as a general statement, then it is sometimes true, right? Depending on the base for reasons people are saying in the chat. And I could have given, as a teacher, I could have given calculate 5% of this and calculate 10% of that. Which one is bigger? I Sorry, I'm just thinking about how I want to word my question. How is that kind of prompt? Calculate 5% of this, calculate 10% of this, which is bigger? How is that kind of prompt different than this kind of prompt that students are interacting with?
Lindsay, I don't have a response to that exact
That's okay.
question, but I do want to share that when I do this always, sometimes never exam questions, if they say sometimes, I always tell them to then provide me with the counterexample.
Thank you. Yes.
For example, if I had said, I had said sometimes, so then I would have said, okay, 10% of a 2,000 base salary versus 5% of a 200,000 base salary, which maybe would take away from the conversation which is happening in the chat right now, because that counterexample might just shut it down. I don't know, but I'm just sharing that when I've done the always, sometimes, never, I always say, if you say sometimes, give me an example that works and give me a counterexample that doesn't work. And that's their justification.
I love that. And I think, yeah, I think using examples, I think for the sometimes, like you're saying, especially, uh, is powerful and then explains it right then and there. And I I would argue that it doesn't shut down the chat because there can still be that conversation or that understanding being developed. Like it's not that it's wrong to, I'm not saying it's wrong to say, oh, I'm going to give students practice calculating 5%, 10%, compare the values, like just like straight up math. I'm not going to say that that's wrong. We do have to develop procedural skill and fluency. And there's a richness added when we also vary how we're asking things and putting a prompt like this, doesn't have to be this one, but like this, and attaching, like Tammy, you say you do, the always, sometimes, never, because it really does provide an opportunity to discuss, to talk about it, to have to make sense of it in potentially abstract ways, and also then come up with specific examples, and reasoning about this idea of the base salary, which I think if we had been working on percentages in my classroom, whether I'm using this as a pre kind of assessment, a formative assessment at the beginning or at the end of a unit, my goal would be different. But I could also see, like, do students understand the relationship with the base, right? Of a percentage of what? And is that something that folks are thinking about? This offers that versus giving them calculation questions. Um, so yeah, you could do it with anything. Multiplying two numbers together results in a larger number, always, sometimes, or never. And then providing reasoning with that sometimes. I love that. Provide a counterexample. Is this always equal to this? A triangle is a parallelogram, right? Like anything that you are doing, if you turn it into an always, sometimes, never, it can force things to go a little bit deeper. Um, all right. What shifts and practices did you see, or do you see the potential for in an activity like that?
I'm just going to unmute for a second because it just kind of hit me, from somebody who was taught math very old school. It was always one right answer and there it is and no discussion, right? So I just love that we're thinking outside the box, we're pulling in different ideas and we're mulling them over and it just takes it that much deeper. So I appreciate that.
Thank you for sharing that. I'll point out one, and if there's anyone that has another one you want to share, I mean, you could probably make a case for several, but one thing that stands out to me is looking for and expressing regularity and repeated reasoning. Just the idea of, can I make a generalization about this or not? Right? And having to really think about the pieces that fit. And if I can make an always or a never generalization, I have to really understand the patterns and relationships and how things are working. And then Tammy adds seeing rigor, um, that conceptual understanding, right? We got to know the procedure and have that to back up our examples, some understanding. And then it could be applying it to real life. Sorry if I'm putting words in your mouth, Tammy, but that one stood out to me as well. All right, I have one last math prompt that we're going to do. Who's done open middle before? Open middle? Oh, I love open middle. And again, because I don't remember if I've said this or not yet today, but these activities are not like to replace all the other things we're doing. It's just like, let's throw these things in the mix at certain points, to give students a different way of grappling with ideas. So here's another way. Graphing points on a coordinate plane. If you would like this calculator, to like think about it, you can, or if you want to sketch a coordinate plane on your paper, that's fine. But I'll give you like 2 minutes to think through how you would answer this. The directions say make 4 points using the integers -4 to 4, and they're all listed at the bottom there, at most 1 time each, so that each point is in a different quadrant. So on that coordinate plane, There's 4 sections. How would you plot these? Or how would you use those numbers so that you have 1 point here, 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 and here, but you're not repeating those numbers? So I'll give you 2 minutes to think through it. If you come up with an answer, awesome. If you don't, awesome. At least start thinking through it. All right, you do not have to share an answer if you don't have one. That's totally fine. But does anybody want to share, like, how are you thinking about this problem? How is it? How are you approaching it? How are you trying it?
In my mind, I was just thinking about the 4 quadrants, and so both coordinates have to be positive in quadrant 1. One coordinate has to be negative, the other one positive to be in quadrant 2. Both coordinates have to be negative in quadrant 3. And the x coordinate has to be positive, and the y coordinate has to be negative to be in quadrant 4.
So without even using numbers,
Correct.
you are just thinking, these are the signs for my quadrant 1, 2, 3, 4.
Right.
And then I could maybe match
Just
things
grab
up.
numbers. Yeah.
Anybody think of it differently? Again, if you have an answer, okay. If you don't, just your thought process.
I just used what Tammy said as well and just went down the line with the numbers.
Yeah, uh I did this part as well and then started plugging in numbers. Um no one used 0. Um so that's interesting. Like that could be a topic of conversation in a class. Like, why didn't we use 0? Um what would this kind of prompt bring up that maybe a traditional coordinate plane worksheet doesn't? Not that that's bad, it has its place, but this could add something. What would this kind of activity add?
Maybe a better visual on what creates where a point lies within a quadrant, like which number kind of puts it in its place. I don't know.
I like that, like generalizing, right? Because that's what we all did, right? It's like, well, I know there's a positive and a positive, or right? And so, but we have to know that and bring that to the table.
I
So yeah,
think this
giving us,
this
yeah,
is a
go ahead.
problem that you really need to have a visual with. I couldn't do this without a visual. I would have to have a grid, me
Yep.
personally. To just see it written out like this is too linguistic. It's too foreign. I gotta see it.
Yes, I appreciate that. And making that kind of tool available to students when you're handing this out can be very, very helpful.
What I really like about this activity, I would typically stand in front of the classroom and I typically would go through the first quadrant, both coordinates are positive. Second quadrant, the X is negative and the Y is positive. I mean, that's how I typically would have done it. But wouldn't this be a neat idea if you hadn't have taught that yet, but just ask them to come up with points? And then if there are students in the room who are like, I can't get one in the third quadrant, to ask other students, well, what could you suggest for them to do to change their numbers so that it will get there? So ultimately, the classroom comes to the discovery of the positives and the negatives. It would be so much more meaningful than the way I taught it traditionally, which was I tell them and then they were expected to memorize it.
Yeah, no, I've been there. I'm like relearning math, right? I feel like so many of us are. And back to what Julie was saying too, to couple with what you just said, Tammy, maybe a scaffold if students are like, wait, I don't know what I'm doing. Maybe we hand out something to students or have it ready for those who need it, and we have something that looks like this, right? Because they would hopefully have before we do this, some experience plotting points as far as X's and Y's and that notation. But if we remind them, and this was the handout, right? Like, okay, here's this visual. Now see if you can come up with it. Could be something, especially if it's like a one-room schoolhouse situation, or one-on-one. And then if you have a class, I love the idea of getting other students involved um, to help each other because like you said, it's definitely authentic and more meaningful. All right, so just a couple last slides and then we'll wrap up here. We're not going to do these. I just want to show you. This one is very similar, but it would it requires different thinking using these digits. Fill in the blanks to create a quadrilateral with an area of 16 square units. Oh my word. Okay, I would definitely need something to plot and be able to do that. But this is it's an open middle. There's a lot of different ways that you could do this problem to get there. So you have to fill in the middle part of the problem in order to then come up with that 16 square units. And so all of these problems are like that. This is one with box plots with certain parameters. So having to engage with those words and different parts of the box plot. So this would definitely be at that more adult diploma, or even maybe some GED, although I don't know if you have to calculate this as much as potentially just read it, read a graph on the GED, comparing functions with rates of change. And the beautiful part of this is you could print this out and have it for students to just fill in on paper. You can also, you can have Google Slides where literally they're pre-programmed for you. Then students could just drag and drop different things to try. So it's very interactive that way. If I go to the Padlet, this is where all the example activities live. So the overall open middle website. And then if you want the Google Slides quick link version, it's starting from kindergarten standards through high school standards. So it is all different levels, but again, creating them in this open middle way of reasoning through, and these are each a slide deck, and you can just choose. They also have some standards here. These are not the CCRS standards, but our CCRS standards were based on Common Core, so a lot of the coding is the same if you are trying to match it up with anything. But these are pre-made, and if you just click Use Template, you can get the editable version. So that is here. A website full of which one doesn't belong prompts, how to facilitate an activity like that is a short video on it. Some always, sometimes, never prompts. You can create them on your own if you want more inspiration. Here are a couple websites that have some statements you could use. So really just lots of things. The last thing I'll point out with Open Middle is this is their worksheet that they have generally attached to everything. And it is first attempt, what did you learn? How will your strategy change? Second attempt, what did you learn? How will your strategy change? This really gets at developing, I think, productive mathematical thinkers. It's expected you're not going to get a viable option, a solution on your first try. Like it might take 6 times, but what are you learning along the way and then applying? So I just love this in general. Like you could use this without Open Middle problems. So I just wanted to point that out. One other thing on this Padlet, and then I just have a couple announcements before I let you go. If you are curious, if you want to read more about the different routines we did today, I wrote a 2-part article a couple years ago about these routines. So feel free to read through that, just again, to see it again. And then there are other instructional routines from the Adult Numeracy Network. This is a viable, I have a bug flying by me, sorry. This is a respected group, the Adult Numeracy Network. And so there are 34 routines. Please don't do 34 routines. I'm not saying that with your students, but like picking 1 or 2 that are really that you think would be really good for your particular setting, and then going with it. So it becomes a routine that students are very, very familiar with. There are lots here, but it tells you how to do it, gives you resources. So something to check out if you would like to. All right. To wrap up, we are, I'm going to, if you like QR codes, you can scan that. Otherwise, I'm going to put the link to this Padlet in the chat. And then I want to share with you a couple of next steps and announcements. So if you want more information, if you haven't gone through the CCRS Foundations course, please enroll and you can complete it. If you have, but you're like, I just want it as a reference to have more detailed reference on all of this stuff, you can still enroll. You don't have to complete the course in order to enroll. When you click on the link in the slides, it's right here. And then you can join the course by clicking here, and there's other courses you see here as well. I did put a quick link on this Padlet too for you. We, on our Atlas website, have a resource library dedicated to CCRS, so definitely feel free to check that out. We record webinars like this one, so there's a playlist on our YouTube channel for Minnesota Adult Education. If you are like, I've made it through all of Hulu or all of Netflix, now I want to watch all these videos. Anyways, you can search for different videos and recordings of past trainings. So again, more resources than you probably wanted. Upcoming PD opportunities. Math Institute, November 7th. It's virtual with Pamela Harris, who is the founder of Math is Figureoutable. Very, very shifty in the sense of like focus, coherence, rigor, and having that kind of guide our instruction and giving students opportunities to demonstrate those practices. So definitely register for that. The MELED conference is coming up. If you are interested or have questions, you can email Patsy. If you want to do the Teaching Reading to Adults mini cohort, applications are due. at the end of next week. And then Language and Literacy Institute will be virtual this year on January 29th and 30th. I'm going to put one last link in the chat. This is the link where you can find all of the, did that copy right? Oh, there we go. Where you can find all of the registrations. So if I were to click on this, for any of the things I just mentioned, you will have quick links. So teaching reading to adults, there's the application. Math Institute, you can register here. Language and Literacy, that registration will be coming, but this is where you can find all the quick links. We keep this updated all of the time. So this is the same link. You can always go back to this link, and you can find it at the top of our website on every single page. So this is a great way to kind of stay connected and to get those links that you need to register. I think that was it. Thank you for staying 2 minutes over. I apologize for being late here, but if you have questions, please email me. You have the slides, you have the Padlet link. It will also be going out in a follow-up email. But I am also would love to interact with you via email or scheduling a Zoom. So thank you for today.